All right. Solo recording this week since no one else can make it, but I want to get through last pieces of call it like basic software items that I think I need to share before we kind of start to get into AI and autonomy and all the different types of techniques and algorithms and things that we leverage in that space. So I'm going to start by basically, really, I'm just going to go through some quick ChatGPT prompts that I've built um, to talk about the two things we're going to cover today. So we're going to cover smart pointers, and we're going to cover like kind of, really virtual and abstract classes, and really like just close out kind of the object-oriented programming descriptions. And so we'll go over those with just a couple examples, and then we'll be wrapped for a lot of the software portions. So let's dive into smart pointers. Smart pointers came about in C++ 2011, I believe. And really, if you remember some of the older lessons where we talked about, pointers and references and memory management, the challenge with just using like native like pointers and references is that if you do that and you don't remember to clean up or delete the pointer or the reference or the memory, that memory persists throughout like the life cycle of the program. And so you can kind of get into a point where you have like memory leaks and big chunks of memory being taken up in certain areas, and you're not sure why because you forgot to clean up pointers. So it becomes messier to manage from that standpoint, which is why C++ is a little bit harder. But it also doesn't require a garbage collection to release the memory. So there's you can kind of in some ways not guarantee, but if you code it right, guarantee that you won't have like locked up memory and items like that for a few seconds, which for real-time applications really matters, even soft real-time. So when it comes to smart pointers, these were introduced as basically think of them as like function wrappers around pointers that make sure you don't kind of have dangling memory, when things kind of go out of scope, or maybe they kind of does a lot of the cleanup of pointers for you, so that you don't have massive memory storages when you're not using things. There's really three types of smart pointers. There is unique, there is shared pointer, and there is weak pointer. I don't have an insane amount of experience with smart pointers, mostly because I didn't program a whole lot when those were first introduced, but I've gotten a lot smarter on those over the years. So I would say that the most common ones that are probably going to be used are unique pointer and shared pointer, and most of the time probably shared pointer. Though that's probably not best practice. That's just what ends up happening. And then weak pointer is used a little bit less. So let's go through each one of these, kind of what they mean. We talk about syntax. So unique pointer is really like an exclusive ownership pointer. And what this really means, and I kind of have it in the comment here, is that, first off, let me just code. We'll do that. We'll do a save. We'll get it started, and then I'll talk about what's going on here. So for a unique pointer, it is really means that the pointer variable like has exclusive ownership over the pointer, meaning you can't like do this thing where you're assigning a piece of memory, a pointer that's pointing to a piece of memory to like a bunch of different variables. You can't do that with a unique pointer. It doesn't allow you to. And so it kind of enforces exclusive ownership. And you basically, if you want to change ownership, you basically have to use the standard move function to transfer ownership to another pointer. So, and make unique, for example, is how you make the unique pointer, and then you've got std unique. This is of an integer. You're kind of printing it out here. functioning just like a pointer, and it's like, hey, I got a variable 42. Well, let's say I want to create another pointer variable. I have to I can't just assign the same memory address to that new pointer variable. I now have to transfer ownership of that memory to the new pointer. And what happens when you do that is that P1 no longer has ownership over this, but P2 does have ownership over this. So P1 no longer owns the resource. And if you try to access the resource for P1, you'll just get an error. But with P2, you do have access to the resource now. So that's basically the difference between unique pointers. Trying to think of a use case on when you would want to use this. I don't think I talked about singleton data structures very well, but think about like a database, for instance. This is kind of not an example you'll see super often, but because databases are kind of their own things. But if you had a piece of data that was shared, was going to be used by multiple sources, but you didn't want people editing it at the same time. You wanted them to kind of edit it in one at a time. Like one person owns the resources. Say it's a class object, they want to change a bunch of variables in the class object, so they will take ownership, do a bunch of that stuff, and then you can transfer ownership to someone else. Then if the original party tries to change things, they can't, but the new party can change things. That's really where a unique pointer comes into play. I think all of these get deleted when they go out of scope. Do they all get deleted? This is pointers. Do these all get deleted when a resource is no longer using them? Short answer is yes, but in different ways. So unique pointer, it's deleted when the pointer goes out of scope. So that's kind of you give a standard local variable and a function. When it's out of scope, that memory gets deleted. Similar thing here. Shared pointer, the resource is deleted only when the last shared pointer is destroyed. So when the count goes to 0, meaning and I didn't explain what that is, so I'll explain that in a second. And then weak pointer, we'll follow that up when I kind of remember what that is. But I'm going to go back to the examples here. So I explained unique pointer. Let's jump. Okay. So the unique pointer, and I'll do our little thing here, or shared pointer. A shared pointer is when multiple owners can own the same object, and it's deleted when the last owner dies. So for example, P1 and P2, which are both pointers, can point to the same piece of memory, and that's totally allowed with shared objects. You can have as many or shared pointers. You can have as many pointers as you want. However, when the last pointer stops using it, then that piece of memory dies. And so use count after scope is 1. Let's see what happens here. So this is P out, use count. You can count how many people have ownership of the pointer, how many variables have ownership of the pointer. So P2 has ownership here, and use count originally is 2, and then that's within a little scoped bracket. So when it goes out of scope, then you only have 1 owner. The last 4 shared pointers, 4 shared pointers. The last goes out of scope. Does it delete the memory? Yes. Okay. So the answer is yes. That's what happens when the last variable goes out of scope. So if this function was were to run after the function's over with, last variable's out of scope, the count goes to 0, and then the memory is actually released from the RAM. So and you would use that when you need multiple parties to access it at the same time. You're not as worried about concurrency or other issues like that. Say you were just like had a class that like had a member that was a list, and you were just kind of appending that list with a bunch of data, didn't care about the ordering or anything, and you have multiple variable entities doing that, you could then use a shared pointer, and those multiple variable entities will then append the class. And eventually, when no one's using it anymore and it all goes out of scope, then the data is kind of released. That's a good example there. See something in the meeting tab needs my attention. Stay in the call here. And then the last one is weak pointer. I'm trying to remember. I used to always ask these in interviews, and I'm kind of forgetting. It's been a little bit what weak pointer is. Non-observing owner observes a shared pointer without extending its lifetime, prevents cycles. So breaks reference cycles, catches observers, back pointers. Give a simpler explanation of weak pointer. Weak pointer, it's a pointer that looks at the object but does not own it. Right, so okay, so that now I remember. So a weak pointer is a pointer that can, look at a variable but has nothing to do with when it's deleted. Like when it stops looking at it, it doesn't affect the count or anything like that. At least I believe that's what it's saying. It lets you safely say if this object still alive without extending its lifetime. So here's an example. You use it looks like you use it kind of with a shared pointer. So, right, so we have a shared pointer owner, and let's say owner is owned by a bunch of different people. And I want another observer somewhere else to come in and like access that piece of memory, right? But I don't want that observer to have any say in that piece of memory staying or being released. So I don't want it to be included in the count of the shared pointer. I can then make a weak pointer and then point to that owner and then use it while it's alive. But if all the other shared pointers go out of scope, then that piece of memory is released and weak pointer won't have access to it anymore. But if weak pointer goes out of memory, that shared pointer's still there because weak pointer just has nothing to do with it. It's only like outside looking at it. It has nothing to do with a use count capability. So that's pointers in a nutshell, smart pointers. Really, the key here is that these are used for memory management, and the objective and good practice is to always use a smart pointer so that it's doing some of that memory cleanup for you, and you're thinking about the use case and the scope with how you're going to use a pointer. So it's very good practice to use. Kind of change the game for C++. So if we go to the next thing I wanted to talk about real quick is all in this code snippet. Okay. Copy paste. So in VS Code, what we're looking at here is just a summary of OOP. I don't know if I ever, when I introduced object-oriented programming, if I ever talked about abstraction, encapsulation, inheritance, and polymorphism explicitly together, but those concepts, those like items right there, when I was doing the factories and talking about, all of the design patterns, these are the key concepts of object-oriented programming: abstraction, encapsulation, inheritance, and polymorphism. And this example just kind of gives you exposure into each one of what each one of those things are. Just to give you like kind of a quick word vomit on these things, abstraction is really the ability to abstract details to higher or to base classes like the earlier classes, and then the inherited derived classes can add more details in terms of like specifying functions and specifying more details and adding more variables and things like that, which you've seen some of before. Encapsulation is really just like adding the functions and the members together inside of one object, which is what we've talked about when we introduced classes and objects. Inheritance is related to abstraction, but it's the ability to kind of derive subclasses from like a higher a higher class structure, and add more and more details. And then polymorphism is the last one. I don't know that I talked about the word polymorphism as much. I can't remember. But polymorphism is the ability, if I have like animal class, to derive both a dog and a cat class separately. And then when I call the make sound function, depending on if it's called on a cat object or a dog object, it might meow or it might bark. So it's the ability to have kind of the same word for a function, but change the inners of the function. Technically overloading the arguments of a function as well, where you have like, you know, add A and B or add A, B, and C. That's technically a type of polymorphism as well. There's a few different types of polymorphism, but anything that is allowing you to basically change the functions in inherited classes that are just different from each other, but have the same name, is where polymorphism comes into play. So here's an example, and this is why I wanted to bring this up before we move on to other things, is because in C++, this gets really like specific, where in Python it wasn't nearly as specific. In C++, we have this notion of virtual classes, and you know, purely virtual like classes are classes that have this virtual keyword in front of it. And what that's going to mean is that you are going to specify kind of the basics of the function, but you're really not going to specify, and usually you say equals default or equals 0. That is like triggering virtual with that equals 0 is like triggering to say that this is a virtual function. The virtual functions are just functioning as like basically like templates. Think of it as like an interface template. You can't use a virtual class, but you have a virtual class and then you derive subclasses off of it that inherit from the virtual class, and you start to specify those functions. So that's what's happening. So this is kind of like your virtual class. And then after that, you have another term that you call abstract class. And abstract classes partially specify details. And so abstract classes you also don't use. You don't implement them, but you implement some of the details. So think of it as like purely virtual is very high level interface. Abstract class is like a little more detail. You're constraining the inheritance structure some, but not fully specifying it to where it can be totally used. And then you go further into fully like kind of concrete classes that can be used when you get to the concrete level. So there's kind of virtual, abstract, and concrete. And some people say that instead of virtual class, sometimes they say abstract base class or interface. But this has virtual functions. This does not have virtual functions. Virtual functions start to get specified to some degree, and then it still cannot be initiated and then or instantiated into an object. But then finally, when you get to the concrete level, it can be. Java has some notions of this. C++ takes it very seriously. C# has some notions of this. Python is a lot more loose. You can't really have virtual or abstract classes in Python, but you can kind of fake it. So that's just trying to give you an idea of what those look like from that perspective. And then on the polymorphism side, in this particular example, if you read the names, I have this abstract interface called sensor, and then I get a little bit more detailed. I'm like, okay, I'm going to derive one of the abstract classes to be temperature sensor. Now I could have other ones that are maybe like vibration sensor or like structure sensor or something like that. But this one is, temperature sensor. And so I take the same kind of class and I build more details into it. And then I start to fill out some of the virtual functions that are here. So something to note is that temperature sensor : public inherits this public class. I'm getting a call. Stand by 1 second. There you go. Just silence that. This particular temperature sensor inherits from sensor, and then you have some other keywords in here. I'll explain what those means. And then you have to fill out, basically what was virtual here. And so this little squiggly, by the way, in C++ is a destructor. It's what you call when you want to destroy the class at the end. But temperature sensor is the constructor for the class. And it's the name, it's just the name of the class, and then you put the arguments in, similar to the self function in Python. And then we get to the concrete class. So the concrete class inherits the temperature sensor class. And then, we specify that this, there's the constructor, it's going to, take in Celsius and some other stuff. So that Celsius becomes the units of the abstract class here, because it's in the constructor of the abstract class. And so it's pulled into this, some of the C++ism, but this constructor. And then you have a read value where we added this function where you're going to read the value, and you're going to make it a constant, and you're going to return, for example, this example, just 18.2. And read value was the original value. And so we're using the override keyword here. When you change the inside of a function, whether it's virtual, abstract, or you're literally just deriving another class, and you want to change the inside of the curly cues, that's called an override in polymorphism. And you use the override keyword. There's also, like I said, the overload keyword, which is if, regardless of the inside, you're actually just changing the arguments to have like different arguments, and you call that an overload. There's a lot of nitty-gritty details in here for your purposes of introducing these concepts. I don't think it's worth going through every syntax variation, but just remember, override is changing the inside of a function after you inherit a class, and overload is changing the arguments. And you can actually have multiple functions, for example, multiple read values in a class, and just change the arguments to have additional arguments. Some have 2 arguments, some have different arguments of different types, some have more arguments, all the same function, different innards. We call that an overloaded function. And then we have a separate concrete class derived also from temperature sensor, just like outdoor temperature sensor. This one's engine temperature sensor. And so it's going to have a constructor and a read value with a constant override, and we're going to return a different value. This is what polymorphism is. It is the ability to change the functions inherited throughout the inheritance tree in different concrete classes and abstract classes. So what happens then is later on, I can end up using these, and I wonder if it gives me an example here. For example, I created, I can create sensor objects. This is fancy syntax to create 2 different sensor objects, array of 2 different sensor objects, outdoor and indoor temperature sensor. And if I call the function read value from both of those, it will return different values, which should happen. Let me just save it here. See, it returned 2 different values, 2 different classes, same function call, 2 different values. That's polymorphism in a nutshell. Interesting concept. Happy to answer questions later if those come up. But it's very critical to a lot of computer science design and code reuse, especially when it comes to interfaces. With that, I think we've completed a lot of the lessons that are kind of fundamentals of software, computer science, etc. To begin to transition to more complex topics, everything from controls to a bunch of how you would employ algorithms like A star, RT star, or neural networks. We could show some examples of those and how they're crafted, and kind of move into further lessons that way. But that's it for this week.